Good day. Today we will be looking at the last question in November 2021, paper 2, question 11. So the first question is a proof. It says in the diagram, chords D, E, EF, and DF are drawn in a circle with the center O. KFC is a tangent to the circle at F. They want you to prove the theorem which states that DFK, so this angle here, is equal. The question wants you to prove that DFK is equal to angle E. So this angle here must be equal to E. Okay, let's start with our proof. So always with the proof, there is generally some construction. Okay, so I'm going to construct a diameter of BF. Okay, and it must be a diameter, and I'm going to connect BE. There is variations to the theorem. This is just one of the ways that you can calculate. Okay, so I'm going to do it on the side here. Let's just erase. Okay, so make sure you also write your construction. Okay, so you're going to say that in construction, you draw diameter. It's important that you say it's diameter so they know that it's going through the diameter, BF and BE. Okay, now we can start. So we can say that BFK is 90 degrees. And my reason is radius perpendicular to tangent. They tell us that this is a tangent. They just want us to prove the angle. So because we know it's a tangent, we can say that BFK is equal to 90 degrees. Reason is a radius is perpendicular to a tangent. Next, we can also say that BEK is 90 degrees. And that is because of angle in a semicircle. So you see that semicircle here. Okay, so we can write it out. B E F is equal to 9. Reason, angle in a semicircle. Okay, so now that we have those two, so we know that this is 90 and we know that this is 90. That is the proof that we needed. So we can say now that DEF is 90 minus BED. Okay, so what I'm saying here is that DEF, I'm saying DEF, okay, I'm going to write it out so you can see. DEF is equal to 90 degrees minus BED. Because this full angle of that part and this part was 90. So DEF, just this part in the triangle here, is 90 minus BED. But BED, which is here, is also equal to BFD. And the reason is angles in the same segment. If you can't see it, I'll draw it for you. So I'm saying that this angle is equal to this angle. So we can say that DEF is also equal to 90 minus BFD. And my reason is angles in the same segment. Therefore, DEF is equal to DFK, because this is now equal. Okay, I hope you understood that. Okay, so here is DFK, which is what we are proving is equal to the interior. Let's go through it again. We constructed the diameter of BF and we connected BE. We said that this angle of BFK was 90, but we're not looking for BFK, we're looking for DFK. Okay, we said that BEF was also 90, angle in a semicircle, but we're not looking for that, we're only looking for angle E here. Okay, that helped me now to find the angle of DEF, because I said DEF is 90 minus BEF. But I know that BED is also equal to BFD because of angles in the same segment, which I showed. And that is therefore going to help me to prove in the final statement that DE 90 minus BED, which is also minus BFD, making them equal in length because they're both a 90 minus the same amount of angle, because this angle and that angle are equal. Okay, that's the easiest way of thinking about it, is that this angle is equal to this angle and they both have a complete 90, making them both 90 minus the same angle, which is why they end up being equal. Okay, let's go to the next question. So it says, in the diagram, PK is a tangent to the circle. Chord LS is produced to P in an M arc point on KP and SP respectively, such that NM is parallel to SK. Chord KS and LN intersect at T. Proof giving reasons that K4 is equal to NML. Okay, here's my K4. So, looking at what I have here, I have this circle, and that's a tangent. So tan chord theorem is going to make K4 equal to S1. Then I can easily use the alternate angles, the parallel lines, to give me corresponding angles, and it's also equal to that. And that is NML. So let's write that out. 0.1a. So I said K4 is equal to angle S1. My reason is tan chord. Okay. Therefore, what I said after that is that angle therefore we can say that angle S1 is equal to M2 plus M3. Reason is corresponding. And when you say a law of angles, you must also state the parallel lines. And M2 plus M3 is what's equal to NML. 4 marks for this question, just for a statement and a reason, a statement and a reason. Okay. Then it says prove that KLMN is a cyclic quad. So let's find KL. So it's KLMN. Well, I just proved K4 is equal to M2 and 3, which means that it's an exterior angle of a cyclic quad. So we have already proved that. So let's just write it down. So angle K4 is equal to NML. Therefore, KLMN is a cyclic quad, and your reason is exterior angles of a cyclic quad. Just 1 mark. Okay. Next it says, now I'm going to move to the next part, so I'm going to erase this out. Okay, it says prove giving reasons that LKN. So where's LKN? LKN, let's use a different color, is similar to KSM. Okay, very small triangles. So let's take a look deeper. So I can tell that M3 is equal to N3, and my reason is angles in the same segment. If you want me to show you the same segment, let's use a color that we can see. Let's use red maybe. So they are in the same segment here in the cyclic quad. Okay, so that's why we're saying N3 is equal to M3. Let's write it out before we forget. So that's my first equal angles. So make sure when you're proving similarity, you say it in triangle LKN and triangle KSM. My first thing I said is N3 is equal to angle M3. And the reason that I said is angles in the same segment. The next, so you have one, the next one is going to be another angle in the same segment, but it's going to be L1 and M2. So taking a look at it, sometimes students find it difficult to see in the same segment, but it's a crisscross, okay? And you just need to find 2. So angle L1 is equal to angle M2, also angles in the same segment, and the last angle is going to be equal because of sum of angles of a triangle, or what else can we say? So the last angle that we have left in these triangles that we haven't found is going to be NKL, so we didn't prove that. So NKL is equal to MSK, and the reason is, where is it? Let's find it. NKL is the last one in this triangle, and the last one in this triangle is MSK, which is here. Okay. Let's highlight them again and see if we can find an actual reason. But more often than not, you can just say sum of angles of a triangle. Okay, because if the first two are equal, we can say the last ones are equal. Okay, but also what I'm seeing here, is that they are also alternating with the parallel lines. But let's just say sum of angles of triangles. So now that we've proved it, we can say that therefore triangle LKN is similar to triangle KSM. Let's take a look at the next question. 5 marks, all for statements and reasons. The next one says if LK is 12 and 3KN is equal to 4SM, determine the length of KS. So now we're using proportions, okay? So let's first analyze this 3KN is equal to 4SM. We can make it into a ratio. So I'm going to divide by 1KN at the top. Going to divide by SM. So 3KN over so KN over SM is 4 over 3. I'm swapping the 3 to the other side. Okay, now that I have that, I'm finding what do they want? They want the length of KS. So let's create our ratio. So it's going to be LK. So here's LK. So LK is going to be over KS. It's equal to KN over SM, which I just found to be 4 over 3. What else do I get given here? I get given that LK is 12 and I want KS. So to find KS, cross multiply. 4KS is equal to 12 times 3, 36. KS is therefore equal to 9 units. 4-mark question for just knowing how to do ratios. Last one says if it is further given that NL is 16, LS is 13, KN is 8, determine with reasons the length of LT. Okay, so LT was not in our triangle, so we need to go and see where LT is here. Here's my parallel lines, here's my parallel lines, here's LT. Okay, and what I can see here now is they've created here's a midpoint theorem triangle situation. So that means we need to prove LT. Okay, so we need to use the ratios in that triangle. So it's going to be LT. Let's create some space here. It's going to be LT over NL. So do you see here's my LT over NL, and on this side it's going to be LS over SM. Let's first look at what they're giving me. They're giving me LT and they're giving me NL. So I have to use the full length. So LT over NL, so it's going to be LS over ML. You use the ratios based off the values, the units that you get given. So because they're giving me NL, which is why I'm making it LT over NL and not LT over TN. Okay. Now LT is what we're finding, yes. NL is 16, they give me that. They give me LS to be 13. They don't give me ML, but they give me KN. Here's KN, which is 8 units. And we can use that to help me find SM, because here is where KM and SM are related. Okay, and in the previous question we said that we had 4 SM is equal to 3 KN. We're now wanting to find SM because that's related to my question. So SM is equal to 3 KN over 4, but we know KN is 8, so I can put that in here. And that is going to give me 6 units. So here SM is 6 units, and we know that LS is 13, so ML is going to be 9. And now we just cross multiply to find LT, and you get 208 over 19. LT is therefore equal to 10.95 units. Okay, this was a very long question, a lot to do with ratios, so I hope you understand. Thank you for watching this video.